Sorry about that, it's cutting up to the third time now. So we're just looking at how they're answering number 2. Let's take this out here. So the graph goes up then down. So here we are told that at f double dash of 2, so that the point of inflection and the second derivative tells us about the concavity of the graph. So if double dash of 2 at this point here, the graph is concave down, okay, at x equal to 2, so therefore the stationary point has a local maximum. Okay, that's another way of laying it out. Okay. So if double prime of 2, so your if double prime of 2 is less than 0, so it's concave down. So the turning point at that point will be a local maximum. Okay. And of course, the second derivative of 4 is positive, which means to say the graph is concave up, which means to say there's a local minimum. Okay. So some theory there that you just need to go over again before you write your final exam. It could come in your mock exam as well. Right, let's look at example 4. Example 4 is on page 172. So 173. So here we are told that f of x equals x cubed plus bx squared plus qx plus r as an x-intercept at 2 and 0, and a point of inflection at 0 and negative 8. Determine P, Q, R and P, Q and R showing all necessary calculations. So where do we start? We know the graph is going through 0 and minus 8. Not so. So my equation now reads f of x, or you'll substitute, you'll substitute 0 and negative 8 into f of x. By doing that, this is an x and a 1. Not so. So, we have 8, negative 8 is equal to 0 cubed plus p times 0 squared plus q times 0 plus r. So that's going to cancel, leave you with negative. Okay. So what do we have now? F of x equals x cubed plus px squared plus qx plus minus 8. For some of you, you could have seen immediately that your r was going to be negative 8. Why? Because that's your y-intercept. Okay. So there we got r. Now, here we are told the point of inflection. How do you calculate the point of inflection? Sorry? Your second derivative. Not so? So my first derivative is going to give you, coming from here, okay, this is right here. The first derivative is going to give you 3x squared plus 2px plus q. My second derivative is going to give you 6x plus 2. Okay? So this was a constant. The 2 falls away. So how do you work out the point of inflection? Work at the second derivative and you set it equal to 0. So what is the x value at which this By doing that, we will then calculate the x value at which the point of inflection occurs. Here we are given the coordinate of the point of inflection. So the point of inflection occurs at an x value of 0. Can you see that? So in other words, if double prime of 0 is 0. Why? Where do I get this 0? I get that 0 from there. That negative 8 doesn't affect this equation that I'm busy with here. Okay, how do we get that negative 8 normally? We substitute that x value at which the point of inflection occurs at. You substitute it into f of x, and you get the corresponding y values. So, in other words, if I substitute f double prime of 0 is equal to 0 into that equation, I then say 0 is equal to 6 times 0 plus 2p. What 6 times 0? 0. So 2p is equal to 0, so p is equal to 0. There I got p now. So I got r, which is negative 8, and p, which is 0. So my equation now reads f of x equals x cubed plus p, which is 0. 0 times x squared is 0, plus qx minus 8. Oops, so what do I do now? We are told that it has an x-intercept of 2 and 0. So what do I do now? You substitute 2 and 0 into this equation here. Okay. So we have 0 equals 2 cubed plus q times 2 minus 8. What is 2 cubed? 8. 8 minus 8? 0. So your q value is also 0. So there you got your p, your q, and your r. Okay, you guys understand? So the equation of this graph is y is equal to x cubed minus 8. Your p value is 0 and your q value is 0. Here is a sketch the graph. I'm sure you guys know how to do that. Okay. I'm going to draw that graph now. As you can see, this is what's going to look like. Okay. I'm just going to copy this. We have done a lot of graphs. So I've done a lot of graphs. So and you guys have written on the graphs as well. So you should know what's going on in terms of this graph here. Okay, that's the answer to number 2. As you can see, the cubic function, x cubed minus 8, if we draw the first derivative, which is f prime x, then it's going to be 3x squared. Okay? Remember, this is your f of x. Your f prime x graph is going to give you 3x squared, which is this graph here, as you can see. And your f double prime of x is equal to 6x. So it will go through 0. If x is 1, y is 6. Or x is 2, y is 12, as you can see there. That point is given as well. Okay? Let's look at worked example 5. Here's example 5 on page 170. 8, 3. Alright, so it says consider the function g of x equal to ax cubed plus g of x equal to x cubed plus ax squared plus bx plus c, which passes through the origin and has a tangent given by the equation y is equal to 24x minus 54 at x equal to 3. So what I normally do is, I just draw this to give me an idea what's happening. Okay? That is positive, so the graph is up. It's a positive gradient, so the graph is going to look something like that. Okay? So the equation of this line is y is equal to 24x minus 54, and this is your g of x graph. We are told that it's going through the origin. Okay, consider the function which passes through the origin. Now let's say the origin is here. It could be anywhere. It's also a point on the graph. And has a tangent given by the equation y is equal to 24x minus 54 at an x value of 3 and some y value. That's the information given. Okay. Determine the value of A, B, and C showing all necessary calculations. So A, B, and C belongs to the parabola. Not so. Right. So if the graph is going through 0 and 0, what do we note at this point? Your C value is 0. Not so, but that's your constant. If it's going through the origin, your y-intercept is 0. Okay? So my equation now reads g of x is equal to x cubed plus ax squared plus bx. Okay. So now we know the graph is going through 3 and some y value. How do we get that y value? We substitute 3 into the tangent. Why? Because why we will substitute the tangent? Because the equation or the point of contact is the same point in your cubic function as well as your tangent. Do you see that? You substitute 3 into your cubic, your parabola, your straight line. You got y is equal to 24x, which is 3 minus 54. Did somebody work that out? It's 72 minus 54. It's 18. Okay? So that point is 3 and 18. Do you see that point of contact is 3 and 18? Okay, so this point is actually on this side. Because I look here, you've got 0 and 0. But it's fine. No? The question wasn't to draw the graph. That is just to give us an idea of what's happening. Okay? So in other words, the cubic function is also going through 3 and 18. Not so? So what we're going to do is we're going to substitute 3 and 18 into g of x. Remembering this is the x and a y. So 18 is equal to 3 cubed plus a times 3 squared plus b times 3. Okay? Which now gives you what is 3 cubed? 27. What is 18 minus 27? Negative 9. So 9a plus 3b. I divide by 3 and make b the subject of the formula. So it's going to be negative 3a minus 3. This equation. Okay? Then we know that the gradient, the gradient at x is equal to 3. The gradient f prime of 3, which is the gradient of the tangent, is equal to 24. Can you see that? At this point here, the gradient of the tangent is 24. How do we know that? It's coming from there. The equation of your tangent. So what we do is, f prime 3 is actually g prime 3. Okay? So I'm going to apply my derivative here. So g dash of x equals 3x squared plus 2ax plus b. Now I take this into account now. So 24 is equal to g prime of 3. So it's 3 times 3 squared plus 2a times 3 plus b. So make b the subject of the formula here. B is equal to negative 6a. What is 24 minus 27? This was 27 here, no? 24 minus 27 is negative 3. Is that correct? Sheila? Right? Right, so this is equation 2. So from here, we're going to do some simultaneous equations there. We set equation 1 equal to equation 2. So it's going to be negative 3a minus 3 is equal to negative 6a minus 3. So you're going to get 3a is equal to 0. So a is 0. So your b value is going to be negative 3 times 0 minus 3, which is negative 3. And there's your b. There's your a, and we have c. So my equation now reads, therefore g of x is equal to x cubed. A is 0, which is minus 3x. And there's your answer. So your c value is also 0. Then it says, if a is equal to 0, b is equal to minus 3, and c is equal to 0, which confirms what we have calculated thus far. Determine the equation of the tangent which is parallel to the tangent at 3. People, if lines are parallel, what do we know? If lines are parallel, what do we know? It has the same gradients. Okay? So I'll answer the remainder of this question tomorrow. Okay? So for homework, just remind me, I forget. Let me just check the work quickly. For homework, I would like you guys to do exercise 13. That's actually the last question. Yeah, those who don't want to keep you during break. So your homework is exercise 13 on page 174. You do for me numbers 1 to 6, 7. 1 to 7. We'll make it 1 to 6. Okay, it's a bit long. 1 to 6. Okay, somebody's asking me at the back for number 7 as well. So I'd rather do number 7 as well. Yes. Okay, so it's 1 to 7. Alright?
Good morning. May I have your attention, please? The following
So let's stop at this point,
please
okay?
report to the office. Mfile Daba,